Imagine this. Your body's elite security force triggers a massive, life-threatening lockdown, causing total chaos, all because of a completely harmless grain of pollen. Wild, right? Welcome to The Explainer. Today, we're diving deep into the dramatic, microscopic mistake known as type 1 hypersensitivity, or, what most of us just call an allergic reaction. We're going to uncover the fascinating, complex, and honestly sometimes terrifying world of what happens when our biology just goes totally overboard. Okay, here's our roadmap for today. We're going to cover the anatomy of an allergy, look at Phase 1, the setup, and Phase 2, the attack. Then we'll go from hives to anaphylaxis, and finally, wrap up with how we go about stopping the reaction. Let's get into it.
Starting off with Section 1, the anatomy of an allergy.
So allergies are basically a massive biological misunderstanding. The word itself comes from the Greek allos, meaning other, and ergon, meaning reactivity. At its core, a hypersensitivity means your immune system is reacting to perfectly mundane outside molecules, like, say, pet dander, a peanut, or pollen, in a way that actively damages your own tissue instead of protecting it. It's this severe, dramatic reaction to something that the vast majority of human immune systems would just completely ignore.
To really grasp this, we need to distinguish between an antigen and an allergen. Now, an antigen is literally just any specific molecule from the outside world. It could be anything, but an allergen is an antigen that actively triggers an allergic reaction in a specific person. So why does it happen to one person and not another? Well, it boils down to genetics. People who react to these allergens usually have a genetic predisposition. Certain genes basically cause their T helper cells to act like super paranoid security guards, turning an everyday antigen into a highly hostile allergen. It's an inherited trait, which is why, if your parents have a biological vendetta against cats, there's a really solid chance your immune system is going to inherit that exact same grudge.
Moving right along to Section 2, Phase 1, the setup.
Picture this. You breathe in ragweed pollen for the very first time. Step 1, your airway's patrol guards. Those are the antigen-presenting cells. Grab that pollen grain. They travel deep into your lymph nodes and show it to naive T helper cells. These are essentially biological rookies just waiting for an assignment. Step 2, because of that genetic paranoia we just talked about, these rookies are immediately primed and transform into specialized Th2 cells. Step 3, these Th2 cells march straight over to your B cells, the body's weapons factories, and order them to undergo what's called class switching. Basically, they stop making standard antibodies and start manufacturing specialized IgE weapons designed exclusively to target that ragweed. And finally, Step 4. These newly minted IgE weapons attach themselves to the surface of mast cells, acting exactly like tripwires. The trap is now officially set.
But how do these microscopic cells actually communicate to build this trap? Well, they use an intricate chemical communication system made up of messengers called cytokines, specifically interleukins. The excited Th2 cells release interleukin-4, which is the direct chemical order forcing B cells to manufacture those specific IgE tripwires. They also release interleukin-5, and this calls in the heavy biological artillery, eosinophils. These are toxic white blood cells carrying chemicals so absolutely potent, they can easily damage your own surrounding tissue just trying to destroy an invader.
All right, that brings us to Section 3, Phase 2, the attack.
So it's months later, and you step outside and breathe in that ragweed pollen again. Those heavily armed mast cells are just waiting in your airways. But a single touch from the pollen actually isn't enough to set them off. The antigen literally has to bind to 2 or more IgE antibodies at the exact same time. This is called cross-linking. Think of it like turning 2 keys simultaneously in a submarine to launch a missile, right? That precise dual connection is the inciting incident. It instantly signals the mast cell to burst open, violently flooding your surrounding tissue with pro-inflammatory chemicals, primarily a heavy hitter called histamine.
Now, this microscopic warfare comes in 2 distinct, devastating waves. First up is the early phase, happening within mere minutes of exposure. Histamine binds to its receptors and rapidly constricts the smooth muscle around your lungs, making it feel like you're trying to breathe through a tiny straw. At the same time, it causes your blood vessels to dilate and leak fluid into the surrounding spaces, which gives you that swelling and hives. But guess what? The immune system isn't done. 8 to 12 hours later, the late phase hits. Chemical communicators called leukotrienes recruit a massive secondary army of cells. This means even when the original allergen is completely gone from your system, new reinforcements arrive to sustain the inflammation and muscle contraction well into the night. It's brutal.
Which leads us to Section 4, from hives to anaphylaxis.
When we map this biological chain reaction onto what a patient actually experiences, a severe allergic reaction is really a multi-stage crisis waged across several hours. As you can see, it starts completely silently on day 1 with sensitization, where the trap is set. It then waits, sometimes for months or even years, for the trigger of that second exposure. Once triggered, it explodes minutes later with those early phase reactions and then strikes a final, delayed time 8 to 12 hours later.
Because of that massive system-wide release of histamine and leukotrienes, the physical fallout is immediate. Now, for a lot of people, it's highly localized to exactly where the allergen hit, causing irritating, itchy welts of hives, eczema flare-ups, or the annoying nasal inflammation of allergic rhinitis. I mean, that stuffy nose is quite literally a localized chemical spill. But a massive allergen load from something like a bee sting, seafood, or a peanut, that can push this localized reaction into a full-blown systemic, life-threatening crisis in highly susceptible people.
And this is the terrifying mechanic of anaphylactic shock. Remember how histamine causes blood vessels to dilate and leak fluid, while simultaneously causing your airways to swell shut? Well, in anaphylaxis, this doesn't just happen in one little patch of skin, it happens everywhere, all at once. The severe leaking drastically drops your overall blood pressure. Combined with your airways constricting, it physically prevents oxygen-rich blood from reaching your brain, your heart, and other vital organs. It's crazy to think about, but the body's overwhelming attempt to protect you inadvertently suffocates its own vital systems.
So that begs the obvious question. How do we stop the body from attacking itself?
That brings us to our final part, Section 5, Stopping the Reaction.
With the immune system acting as an overzealous bodyguard causing massive collateral damage, we can't just wait it out. We have to intervene and forcefully de-escalate the situation using modern medicine. To counter this biological chaos, we use 3 primary chemical breaks, each targeting a specific mechanism of the attack. Antihistamines do exactly what it sounds like. They cap the H1 receptors, literally shielding your tissue from the histamine to stop the leaking vessels and airway spasms. Corticosteroids, they're deployed to dampen that broader, overarching fire of inflammation caused by the secondary immune cells. And in a severe crisis, epinephrine is the ultimate rescue tool. Usually given via an EpiPen, it forces those dangerously dilated blood vessels to aggressively constrict, reversing the fatal drop in blood pressure, opening the airways, and literally stopping anaphylactic shock in its tracks.
But there is a really crucial warning here. Remember those sneaky late-phase reactions driven by the leukotrienes arriving 8 to 12 hours after the initial exposure? Because of this delayed second wave, a patient can seem to fully recover after taking steroids or using an EpiPen, only to crash again hours later when the reinforcements arrive. This is exactly why seeking immediate emergency medical care is absolutely mandatory, even if you feel completely fine right after the initial treatment. You just can't risk it.
We've traced this incredible journey from a simple, microscopic misunderstanding to a massive biological warfront. And it really makes you wonder if our immune system possesses the raw, overwhelming power to nearly destroy us over a simple peanut, what other incredible, untapped potential is hiding inside our own cells? I'll leave you with that thought to ponder. Thanks for joining me for this explainer, and as always, keep asking questions.